Welcome my viewers to my YouTube channel. In today's video lesson, I'm going to be teaching you mathematics. If today is your first time for coming across my YouTube channel, please do well to subscribe. If you are a student preparing for WAEC, JAM, post-UME, and other professional exam, please do well to subscribe to this channel. In today's video lesson, I'm going to be teaching you circle geometry or your circle theorem, as you can see on the board. Now, we are going to start with the basic theorems of circle geometry. Then in our subsequent video lesson, we are going to continue from where we stopped in this lesson. Now, look at the board. You see Theorem 1. You must know the theorem for circle geometry in order for you to be able to solve problems involving circle geometry. Now, let us look at Theorem 1. It said that angles at center. Okay, you know what the center of a cycle is, right? He said angles at center is twice the extended angle. The extended angle is the angle at the circumference of a circle. The circumference of a circle means the distance around a circle or the edge of a circle. Okay, if you look at the diagram, you'll be able to picture the angle at the center. If O happens to be the center of this cycle, it means that X, as you can see, there's X here, is the angle at the center, and your Y is the angle at the circumference, or what we call the extended weighting angles. Are we together? Okay. Now, according to this theorem, it said angle where they the center is 2 times the angle that is at the edge. That is to say that X is 2Y. That's what it means. It's as easy as that. So what does that mean? It means that if this guy is 5, this one will be 10. If this one is 20, this one will be 40. If this one is 30, this one will be 60. And if here is 60, guess what here will be? 120. Why? The angle at the center is twice the angle at the circumference. That is so clear. So X is equals to weighting 2Y. Now this same diagram here is the same with this, but in another word, in another form. In this diagram, that's figure 1b, is the same with this, still on the first theorem. Now, this is the angle at the center. What is the angle at the word circumference? Whether it is up or down, it does not matter. You just have to know that there's what we call angle at center and there's what we call angle at the circumference. So this remains the angle at the circumference because at the edge. Why this one is the angle at the center? Is that clear? But what you have to do is this, because sometimes it can be very tricky. You see this angle now, you see the direction of this arc of this angle and this one, they are the same. So it means that they should be corresponding. They must be facing the same side. That is why I decided to draw this diagram for you. Did you see that this angle and this one, they are facing the same side so that you don't mistake it? The two angles that are working with Theorem 1 must be facing the same direction. Is that clear? Now, let me take you higher a little. If I have an angle here, which I'm going to label as angle E, for instance. Let's label this angle as angle E. If I label this angle as angle E, if I label this angle as angle E, do I now say that angle E is 2 times the angle here? No, because the direction where E is facing and the direction of this B is not the same. So it means that if peradventure I have an angle here, I have another shape here like this, another shape here, okay, which I will probably call F, for instance. If here is F, I can tell you that this angle E is 2 times angle F. Yes, because E and F correspond to each other. So the bottom line here is that the angles must correspond. So let's take this out so you don't get confused. Let's take this out. So they are corresponding. Did you see it now? I didn't say they are corresponding angles, but they are corresponding. Now let's go to Theorem 2 of your circle geometry. Theorem 2 says that angles by the same segment are what? They are equal. Do you know what they call a segment? A segment is the unequal section of a cycle. Let me put it that way. For instance, if I have a cycle like this, watch this. If this is a circle, remember that if the line passes the center, you have divided the circle into two equal parts, isn't it? Now, but if the line does not pass through the center, you have divided into two segments. For instance, if I take my line here, this part and this part, are they equal? No. So this part and this part are referred to as a segment. So segment are the unequal part of a word, circle. So this one now is a segment. If this segment produces an angle here like this is angle by this segment. You dey see am now? Yes. If this same segment that you are seeing, the one we have drawn the board, now still produce another angle here. Are you seeing it now? Which we call this angle. You will now see that these two angles here came from this particular weighting segment. And because they came from the same segment, it means that they are what? They are equal. So we need to know that angle that came from the same segment at the circumference of a circle are equal to each other, as you can see. Now let me produce the segment out of this. Let's draw a line here this way. This is a line. So don't forget this is a segment. This segment produces angle. This segment produces angle. So the angle that is here and the angle that is here becomes equal to each other. Why? Because they came from the same word, segment. This must be noted. Now, if you watch very well, we say that this is A, meaning that they are equal to each other. So if this is 30, yours will be 30. If there is 60, yours will be 60, because they are coming from the same segment. Is that clear? Thank you very much. Now, follow me carefully. Don't be distracted. Come closer. Now see, if we have another segment here like this, as you can see, remember I told you that a segment is the unequal section of a circle, isn't it? Good. So this guy now is a segment. See, if I have a cycle like this and a line cut like this line is called a chord. Although this is not our focus for now. This is called a chord. But this part is called a what? A segment. This part is called a what? A segment. Why is it called a segment? Because the two parts are no longer equal. If they were equal, it's no longer a segment. It's called a semicircle. But if they are not equal, it's called a segment. So this theorem is based on a segment. So you see that this segment now produces angle called A. See this angle called A. See this segment now that I'm showing you, this one. This segment is the one that produces this angle, and still went as far as with this angle. So this angle and this angle, they are also equal to each other. So take note, angles by the same segment are equal. A segment is the unequal section of a word, cycle, that is produced by a chord. Theorem number 3. The angle extended by the diameter or semicircle is a right angle. You know what a right angle is? A right angle means 90 degrees. Now, if I have a cycle and a line passes through the center, that line is called weighting a diameter. Now, if this diameter now produces an angle that is at the circumference, that angle that a diameter produces is called a right angle. So we can say that this angle is equals to weighting at 90 degrees. That's theorem 1, theorem 2, theorem 3. Okay, so we are going to take theorem 4 and 5. Now let's quickly go into theorem 4. Let's look at this theorem 4. Theorem 4 says that the sum, don't forget that sum simply means weighting and addition. The addition of two opposite cyclic quadrilaterals. You know what a quadrilateral is? A quadrilateral is a plane shape that has 4 edges or 4 sides, as you can see, like a rectangle, a trapezium, parallelogram, rhombus, kite. They are all quadrilateral. They have 4 sides. Okay? Is supplementary. What is a supplementary angle? A supplementary angle is the angle that sum up to be what? 180 degrees. So the sum of two opposite cyclic quadrilateral. Now, like I told you, a quadrilateral is a figure with 4 sides, but a cyclic quadrilateral is when the 4 side touches the what? The circumference. For instance, if I have a cycle this way, now please watch this very well, and I have a quadrilateral here like this. This is a quadrilateral, in case you don't know. For this quadrilateral, it's not called cyclic quadrilateral, not at all. It is not called cyclic quadrilateral because of what? Because the four sides do not touch all the parts of the circle. Is that clear? Good. So because it does not touch all the parts of the circle, it is not a cyclic word quadrilateral. Take note of that. That must be noted. Again, if you watch very well, you will see that these two guys are opposite to each other, as you can see on the board. These are opposite cyclic quadrilateral. Okay, now because they are opposite, they said the sum of two opposites cyclic quadrilateral is a word supplementary. That means it's 180. That is to say, we can say that this A and B are opposites. If A and B are opposite to each other, we can add them. So we can say that A plus B is equals to 180 degrees. That is what they meant when they said the sum is supplementary. Is that clear? Again, C plus D is also equals to 180 degrees. So the sum of two opposite cyclic quadrilateral is equals to a supplementary angle. Thank you. Let's go to Theorem 5. Theorem 5 says that the exterior angle of a cyclic quadrilateral, it looks like this one and this one, they resemble each other. But what he's saying here, he said the exterior. You know what exterior means? The word exterior means waiting outside. It means the angle which is outside the quadrilateral, the cyclic quadrilateral of a side quadrilateral is equal to the opposite interior. The word interior means waiting inside. So there is a relationship between outside and inside for a cyclic quadrilateral. This must be noted. Now, this guy is inside. It's called interior angle. This guy is outside. It's called exterior angle. Remember that if I have an angle here and this one, they would have summed up together to give us waiting 180, like this theorem. Then I said that the angle that would have summed up with this to give you 180, the exterior angle of that particular angle is equal to the opposite of the interior, which will make us to have x equals to waiting y. Take note of that. This must be noted. Now, don't forget we have over 13 theorems of circle geometry, but we are going to pause in Theorem 5 in today's video lesson, and I'm going to take just 2 or 3 questions to explain better. Then in our next video lesson, we'll take the other theorem. Now we are going to take this simple question 1 and question 2. Please watch me carefully as we solve this question together. In the diagram below, find the value of x. This is a JAM question as well as this. Find the value of x. Now, remember I told you that the angle at the center and the angle at the circumference must be corresponding. You must note that. It must be noted. Okay? Now, watch this question carefully. I said that the angle at the center and the angle at the circumference, if you must use Theorem 1, they must be facing the same direction. That means they must correspond. Okay? Now, if you watch very well, see this angle here is facing downward. This one is facing upward. It means that they are not what? Compatible. So what do? You need to understand a simple logic here, that there is an angle here also, which is also called the angle at the center. It is this angle that works with this angle. Remember the diagram I drew for you in Theorem 1, okay? Now, if I bring out this angle that is here like this, and I call this angle y, do you know, class, that this angle y and this angle will give you 360 degrees? That is the sum of the angles at a point. So let's quickly get this angle y. Let's do that quickly. We will say that y plus 156 is equals to 360 degrees. What is your reason? Sum of what? Angles at a what? A point. Please, you must give your reasons whenever you are solving problems in circle geometry. Your reasons must be stated. If you are writing WAEC or NECO, you must state your reason. Okay? So how do we get y? Y becomes 360 minus 156 degrees. Let's do that quickly. 360 156. Here you have 10 minus 6, 4. This now remaining 5. 5 minus 5, 0. And this 3 minus 2, 1, 2. So what you have is what? 204 degree. Wow, that's very interesting. So if y is 204, remember that y and x, they work together. And by first theorem of circle geometry, say that the angle at the center is 2 times the angle at the what? Circumference. Please state your reason. Angles at center, okay? Angles at center is equals to 2 times the extended weighting. Angles. Please, this must be noted. Your reasons must be stated. Now, that means we have gotten our answer already. What's the value of y? It is 204 equals to weighting 2x. So we are looking for x. Divide both sides by weighting by 2. Divide here by weighting 2. This one cancel this. X will now be 204 over 2. That's 102 weighting degree. You see that it's very cheap. So the answer is what? Is B. Now let's go to question number 2. Question number 2 says find the letter G in the what? Diagram below. How do we solve for G? Very easy. It is very easy to solve for your word, your letter G. What do we simply do? Let's quickly do this, please. Let's do this quickly. Should I label this angle as angle X? I think it will be important. Let's label this angle as angle X. Do you remember that the angle here and the angle here are 2 opposite cyclic quadrilateral, and that when they are added together, they give you 180? Theorem 4. So we can say 97 plus x is 180 degree. What is your reason? Sum of opposites, okay? Cyclic weighting quadrilateral. Please take note of this. It must be noted. X will give us 180 minus 97. X will give us 180 minus 97 will give us 83 what? 83 degree. Yeah, 83 degree. Now if you have a 3 degree as your X, remember you are looking for letter G. Can we please do this? Look at my hand as I trace this triangle. This is a triangle. Please, it's a triangle. And you know that the sum of the angles in the triangle is equals to weighting 180. So we can say 63 plus x plus g will give us what? 180. So let's do that. 63 plus x plus g is equals to 180. What is your reason? Sum of words, angles in a word, triangle. Please, it must be noted. Now, what do we simply do? Remember that x is your word, 83. So you have 63 plus 83 plus g is 180. Can we quickly add 63 to 83? 83, 63. This will give us 6. 8 plus 6, 14. So you have 146 plus g equals to 180. G will give us 180 minus 146 when you collect like terms. So your G will give us 180 minus, I think it will give us 34 degree. Yeah, 34 plus give us 1. So the answer is what? We have just 2 questions to go. Now let's take number 3 question. Number 3 question is from UME, that's JAM. 2004, number 9. Let's solve this question. From the diagram below, look at the diagram very well. Find PXO. PXO. You're looking for the angle that is here. Permit me to label the angle as X. So let's call this guy X. Wow. And you must also know that if this is the center of the cycle and this line is here, it means that this line is a radius. And this line is a radius, it means that this one is also a radius. And when you have 2 radius, 2 lines that are equal in a triangle, it's called an isosceles triangle. And the base angle become equal. For instance, if I have a triangle like this, watch this carefully. If this line is equal this line, it means that the angle here and the angle here are the same. So if this one is x, this one will be x. If here is y, it will be y. So permit me to say that here is also x. Here is also x. So you have x here and you have x here. Is that clear? Now let's watch this. Let's solve this question carefully. Now, remember again that this angle 20, 35, and this angle here will give us a triangle which is what? 180 degrees. Is that clear? Yes. So I'm going to call this angle P arrow Q. That's what I'll call this angle. So let's do that carefully. Now we have 35 degrees plus 20 degrees plus P arrow Q. Come. They did not tell us to find this guy. No, but we need it to solve our problem. Equals to 180 degrees. Remember, it is sum of a word, triangle. That is your reason. Now, this plus this will give us 55 degrees plus P arrow Q equals 180 degrees. P arrow Q will give us 180 minus 55. And what would that give us? 135, right? 180 minus 55 will give us 135. Yeah, 125. Yes, 125. So you have 125 degrees. Now, if this angle here is 125 degrees, what would this angle be? Remember that this one is angle in a straight line. And this line is what? 180. So if here is 125, what do we call this angle? It is called P arrow S. What would this angle be called? This is 125. Here will be what? Will be 55. Now, so what do? We can say that P arrow S, which is this angle that is here, P arrow S is equals to 180 minus 125. I told you that the angle, this one and this one, is a straight line, as you can see. So this P arrow X will be equals to waiting at 135. So if you have P arrow X, okay, this and this is 180. So if this one is 125, it is 180 minus this. So 180 minus this will give us waiting 135 degrees. That's interesting. Okay, sorry. 125 degree. This and this gives us 180. If this one is 125, it means that we have 180 minus 125, and that will give us 55 degrees. So this angle here, the angle that is here, the angle here is 55 degrees. How do we get the angle at the center? Remember, the angle at the center is 2 times the angle here. Okay? Angle at the center is called POX. So we can say POS is equals to 2 of the angle that is here. What's the angle here called? It's called P arrow X. So you have 2 of P arrow X. What is your reason? Your reason is that angles at center is 2 times the extended weighting angles. Yeah. So POX will give us what? 2 times this angle 55. Remember that this angle is 55. That will give us 110 degrees. Now, what did they say we should find? We were told to do what? To find the value of what now? From the diagram above, find the value of POX. PXO. PXO. Looking for this angle, the angle X. Remember I told you that this angle and this angle, they are the same. Now that we have gotten the angle here, what's the angle here? The angle here is 110 degrees. So 110 plus S will give us weighting at 180. So we can say 110 plus X is equals to 180. So what do you have? 110 plus 2X is 180. 2X will give us 180 minus 110. So therefore 2X will give us 70 degrees. S will give us 70 over 2. S will give us 35 degrees. So the angle we are looking for is 35 degrees. Okay? The answer is what? C. Now let's quickly do the last question for this video lesson. The diagram, find the value of X in this diagram. How do we calculate for the value of X? Very, very easy. Are you seeing that there's an angle here? Let's call this angle Y. This angle plus this angle plus this angle give us weighting 180. So we can say Y plus 81 plus 53 is equals to 180. What is your reason? Sum of angles in a triangle. Good. So 81 plus 3 will give us what? 81, 53. Here will give us 4, and here will give us 13. So you have y plus 134 equals 180. So y will give us 180 minus 134. Y will give us, let's do that, 180, 134. Here you have 10 minus 4, 6, and here is left with 7. So 7 minus 3 will give us 4. This will give us, so you have 46 degrees. That's the value of the angle here. Do you know that the angle here and the angle here, they are two opposite angles of a cyclic quadrilateral. So they will sum up together to give us what? 180. So we can say y plus x is 180 degrees. What is our reason? Sum of opposite words, cyclic weighting quadrilateral. So remember that your y is 46 degrees. Is that clear? Good. So if you have 46 degrees, we have that y, which is 46 degrees, plus this x is equals to 180. So x, collect like terms, you have 180 minus 46, x will give us 134 degrees. So the answer to this question is what? 134. Thank you very much. We have come to the end of today's video lesson. If today is your first time for coming across my channel, we have a lot to offer you. Please do well to subscribe and also like. Okay, if you have any questions to ask as regarding what I just told you, can send it to me on the comment section. Thank you very much. I'll see you in my next video.